Okay, we're continuing to look at similar polygons. Today we're going to look at ratios in similar polygons. The first thing we're going to talk about is what a proportion is. A proportion is an equation stating that two ratios are congruent. And you've seen this before. For instance, if we have A over B equals C over D, we have two ratios and we're saying that they're equal to each other. Now what this cross product property right here says is that I can take the factors between and basically cross multiply so that we get A times D, and we say that that is equal to B times C. So let's look at this example. We've got a word problem. Fernando conducted a survey of 50 students driving to school and found that 28% or 28 owned their cars. So 28 out of 50 students own their cars. Now we're going to compare that to 755 students who drive to school. How many own their cars? Well, if we put 28 as the number that owned their cars out of 50, we don't know the number that owned their cars over 755. And at this point, we're going to cross multiply to solve for our variables. So you have 50x equals 28 and that's 21,140. We divide by 50 and we find that x equals, what is that? Let me multiply that real quick. 21,140 divided by 50 equals 422.8, or we'll round it to, since we're talking about people, 423. So about 423 students would own their cars out of 755, because we have two proportions that we're saying are equal to each other. Okay, two polygons are similar. Now we're talking back about shapes, so that's just an example of ratios and how to cross multiply. Now we're going to talk about two polygons are similar if and only if their corresponding sides. Now similar is different than congruent. Similar means they're not exactly the same, but they have the same shape, but not the same size. So the sides are not going to be congruent or the same length, but they are going to be proportional. And their corresponding angles are congruent. So let's look at this example that we have right here. We have rectangle ABC and rectangle WXYZ. We are determining whether or not they are, let me get that, are similar. So we're going to find BC, which when we find BC, it's 16. And XY, those are corresponding parts of that polygon. So 16 over 10, simplified to 8 over 5. And if we found the decimal for that, we get 1.6. Then we'll take AB, which is 12, over XW, which is 7.5. And if we found the decimal for that, we'd see it was also 1.6. Therefore, because the ratios are the same, the polygons are similar. And the similarity ratio is 8 over 5, or 1.6. Okay, looking at B here, we're doing the same thing. Okay, so we've got, in this case, KL is 5, that right there. PQ, this corresponding side, is 6.25. And if we found the decimal for that, we would see that it's 0.8. Now then we look at Kn, which is 3, and PS, which is 4. Well, that decimal is 7.5. These are not similar because those two ratios are not equal to each other. If they're equal to each other, then it would be congruent or similar. Okay, looking at this, we have two different, we need to learn how to label the different parts. Corresponding sides would be, let's look at the corresponding angles. They're the easiest. In fact, they're written in a way that corresponding, just like if they were congruent shapes. So angle A is going to correspond to angle W. So in similar figures, the angles are congruent. So angle A is congruent to angle W. Also, angle B is congruent to angle X. So I could look at the picture. I could do this without the picture. Angle C is congruent to angle D. And the last one, angle D is congruent to angle Z. And that last one I did should not be D, it should have been Y. There you go. Now, corresponding sides. Again, we can look at the first two letters, AB and WX. So what sides are corresponding? We can write those as a ratio. AB corresponds to WX, which should be equal, since if they're similar, to BC over XY, which should be congruent, which should be equal to CD over YZ, which should be equal to AD over WZ. And you should be able to do all this without the drawing if we're given this statement right here. Now the scale factor, what are we multiplying 5 times to get, or 15 to get to 5? Well, 15 times 1/3 equals 5. So my scale factor is 1/3. Remember, we're going from large to small, so we know that it's going to be less than 1. So my scale factor is 1/3. Okay, now we have another rect shape. We have rectangles here. We're going to use these ratios to show that these shapes are similar. We have 2 corresponds to 7, so we're going to say 2 over 7. And if we find the decimal there, it's 0.2857. It's more than that, but we'll just stop there. Then we have 6 over 21. And when we do that, we get the exact same decimal. That means they're proportionally equal. 2 over 7 equals 6 over 21. Therefore, these two rectangles are similar. Now, what else could we have used? We could have used 7 over 2 equals 21 over 6. That could have been another thing we used. Now, look at this example. Lynn claims these shapes are not similar. When she compared the heights, she wrote 2 over 7, which we did. Well, then she wrote 21 over 6. What's wrong with that? Well, that would not be, they would not be equal in that case, but if you'll notice, we wrote the 2 on top and the 7 on bottom. The 2 comes from the smaller rectangle, the 7 comes from the larger one. If that's the case, the next ratio that we write has to start, just like the 2 started on top, the 6 has to be on top, 21 has to be on bottom. So we would have written that as 6 over 21, which is what we did right here. Okay, let's look at some more examples. Here we have a pair of, each pair of below is similar. Find the missing value. So we're going to find out the value of x, but how we do that is we write a ratio, of course, with corresponding sides. 2 over 4 equals 6 over x. Now we cross multiply. So we get 2x equals 24. What does x equal? Divide by 2. X equals 12. Okay, look at this example. Again, corresponding parts. I'm going to take the 4. It corresponds to the 3. 4 over 3 equals, I started with 4, so I'm going to start with the x. X over its corresponding side, which is 6. Cross multiply. 3x equals 24. Divide by 3 and x equals 8. And then we have this question. It says that the perimeter is 60. Well, if the perimeter is 60, we can find the missing widths or heights. 21 is here, since it's a rectangle. So 42 of the 60 is already taken up by those two lengths, leaving us with 18. Now these two sides are congruent, they're equal, so if I divide 18 by 2, I should get 9. That means each side is 9. Now I can do my ratio. 3 over 9 equals x over 21. Cross multiply, 9x equals 63, divide by 9, and x equals 7. Okay, now, the perimeter of the small rectangle in part C above is what? Well, it's going to be 3. The perimeter is when we add them all up. That's 3. We said x was 7, so that's 7 and 7. It's going to be 20. Find the scale factor. If we're going from 20, or if we're looking at each side, for instance, take 3 and then take 9. What are we doing to 3 to get to 9? We're multiplying it times 3, aren't we? Did we multiply 7 times 3 to get 21? Yes. So find the ratio of the perimeters. Well, we have 60 here. The perimeter was 20 of my smaller one, so we have 60 over 20, which is 3. What do you notice about the two perimeters? They are the same. Now find the areas. The area of the small triangle is 7 times 3, or 21. The area of the large triangle is 9 times 21, which is 189. Find the ratio. Well, that would be 189 over 21, which if you simplify that, you get 9. What do you notice? How does 3 relate to 9? Well, the ratio of area is going to be the scale factor squared. And that's just kind of some extra information for you. Nothing really on the assignment having to do with that. And looking at some problems we have here. Number 2, all you're really doing in this example is listing all the corresponding parts. Again, you can do it without the picture because they've given you this statement right here. Go back and look at the example that we did together if you need some more help on that one. Determine if they're similar. How are they similar? If all the angles are congruent and all the corresponding sides have the same scale factor or proportion, then it's going to be congruent. So on number 4, all the angles are congruent. We just have to find corresponding sides. For instance, 8 corresponds to 4, 6 corresponds to 3, and 12 corresponds to 6. Notice that they all simplify to 2, don't they? Since that's the case, they are similar. 5, 10, just like that problem example from above. On number 12, let's see, what are we doing? We're looking at it, writing a similarity statement. So they're similar. Again, similar. Look at 12. Are those similar? Look at the angles. This has a 90-degree angle, and this one does. This one has a 39, but this one doesn't. If the angles aren't congruent, then they are not similar. So number 12 is not similar. Now look at 15. The angles are similar, so now we have to prove that they're similar, that the shapes are similar by looking at the ratios. 6 over 4 should be the same as 8 over 6. Well, that simplifies to 3 over 2. That simplifies to 4 over 3. Those aren't equal. This is not similar because the sides are not proportional. Okay, hopefully that helps you with the assignment. That is it.